Okay, so if you're asked to simplify radicals, what it means is it wants you to take this radical of square root of 48 and then see if you can factor out something that you can take the square root of nicely. Like numbers we want to think of are like the square root of 4. That's nice because that makes 2, makes an integer. Square root of 9 is great because that makes 3. Square root of 16, if you can take that out, makes 4. Okay, so we're looking for all those types of square roots. Because we have this rule about radicals, okay? If you multiply two square root numbers, they can become one big happy family inside this radical here, right? 2 times 24 makes 48. But that doesn't help us. That doesn't simplify it because square root of 2 isn't an integer, square root of 24 is an integer. So we want to think of something we can take out of both. I know 4 can go into 48. So let's just start with that and see if we can simplify any more. What do we got? 12, right? Because 4 times 12 makes 48. So that's simplified because square root of 4 is just 2. They want to check the radical, see if there's anything else. I can take another 4 out of this radical. So this is 2 square root of 4 times square root of 3 here. And again, I got to make it so when I factor it out, square root of 4 times square root of 3, that makes square root of 12. I could get back to where I was before. So remember, these are multiplying. This is 2 times the square root of 3. So my final answer that I'm going to type in Newton for this question is 4 square roots of 3. Okay, 4 square roots of 3. All right, let's see if there's a different one in the next one. Yeah, let's do this one because it's got a variable. Same idea. Want to reduce it if we can. Simplify completely, assuming x is greater than 0 and y is greater than 0. That's because you can't have the square root of a negative without using imaginary numbers, right? I don't know if Newton's going to prefer us to leave because a square root means you're raising something to the 1/2 power. Okay, so like the square root of x to the 6, that's x to the 3rd. Because a 1/2 power on top of another power makes them multiply. 1/2 times 6 makes 3. But I'm looking at these numbers. Look, that's a 3 and that's a 9. Those aren't divisible by 2. The 1/2 power trick doesn't help us reduce. But we can at least reduce this square root of 36. Okay. I know the square root of 36. So I know 36 is divisible by 9. Oh, wait a second. Hold on. The square root of 36. Square root of 36 is just 6, right? So you could break this up as separate square roots like this in your head. And the square root of 36 is just 6. Yeah, I don't know. That's where I would leave it. Let's see if this is what Newton is looking for. No, it wants us to simplify. So what we can do to, I guess, further break it down, I wouldn't call this simplifying it, but I guess it wants you to break it down into square roots that we can simplify nicely. Look, check me out here. The x squared and x to the first, if you were to multiply those two numbers, that would make x to the 3rd, right? Because x squared times x to the first, the powers would add up to make x to the 3rd. And then same thing over here. I'm going to do y to the 8th, an even power, and then square root of y to the first. Again, 8 plus 1 would make 9. And the reason I did this is because of what I said at the beginning of this question. Because if you have a square root, it's a 1/2 power. So powers on top of powers multiply. And then same thing here. Y to the 8th to the 1/2 power, that makes y to the 4th. So we got 6x. Oh, I didn't copy this down, sorry. 6xy to the 4th, square root of x, square root of y. Let's see if it likes that any better. Square root of, x, y to the 4th, square root of x. Oh, that went up in the exponent. We don't want that. Square root of x, and we just make it all square root of x, y, all under one radical. Okay, that's what they're looking for. So they do want you to make the power inside the radical as small as possible. So if you were to add 400, 441, Is that a perfect square root? Yeah, that one works out nicely. So you just have to add first and then apply the square root. Okay, so you're going to do the same thing with this one. So we got square root of 18, and then I'm breaking up as separate square roots. X to the 16th and square root of y to the 33rd. Now it doesn't matter the order you do them in, okay? You could take care of the top first and then try to simplify, but I'm breaking them up as separate square roots. Okay, so if I look at just the top, square root of 18. Actually, it's going to be simpler if we do this. Look, if you have a radical divided by a radical, the numbers inside the radicals can just divide, okay? Square root of 18 divided by square root of 2 makes square root of 9 up top on the fraction. Okay, it's just like if you have the radicals multiplied to radicals. Square root times square root, you can multiply the numbers inside. And then x to the 16th being square rooted, that means x to the 16th to the 1/2 power. So the power on top of a power multiplies. And then we're going to do the same thing we did in the last one to make I think I said Alex earlier. That's another program I use to make Newton happy. Okay, that's y to the 32nd times y to the first, right? I made it have an even power so that we could reduce it. We already took care of that too. Square root of x to the 12th is x to the 6th, because 1/2 times 12 makes 6. And then do the same thing with square root of y to the 13th. That's square root of y to the 12th, and then square root of y. Okay, so this one's going to simplify nicely. That's gone, right? We got square root of 9 makes 3. And now we have x to the 8th divided by x to the 6th. When you divide two numbers of the same base, the powers subtract. So that makes x to the 2nd. Then same thing here. You got square root of y to the 32nd divided by square root of y to the 12th. The powers can subtract because they're both inside a radical. So that's y to the 20th. 32 subtracted by 12. And then we know how to simplify y to the 20th now, right? Because it's a 1/2 power it's being raised to. And that's it. Okay, I think that might be all the types you see. Yeah, that's going back to what we've seen before.